Welcome back. We're on question 12 of the 2020 sample paper. Okay, so this is a functions and a trigonometry question. The coordinate diagram below shows a graph of a function y equals cos of x. Okay, from 0 to 90 degrees. Okay, here we have it. It's a decreasing function between 0, and use a calculator to work out the sine of 90 degrees. Okay, so we clear the calculator, we put the sine function and the sine of 60 degrees we need. Okay, you can close the bracket on the argument, but you don't actually have to. It will still work it out, and we have the exact values, root 3 over 2, but they want correct, so I'm going to write that down. The sine of 60 is equal to root 3 over 2. We know that from the reference triangle anyway, and then as a decimal approximation we can go shift equals, and it'll be 0.866, and it'll round up to 0.87. Okay, now but by the way, we know from symmetry, and I'm going to talk to you about it in a second, that the sine of 60 is the exact same as the cos of 30, because sine is going to go like this. Okay, and there's this symmetry around 45 degrees. So just in terms of our graph here, it happens to be the exact same as that value there, 0.87 up near 0.9. Okay, now we're to draw the graph of y equals sine of x. This was cos x, and this is sine of x on the diagram above using the same axis, scales and domain. They tell us that the sine of 0 is 0 and the sine of 1 is 1. So they tell us these 2 points exist. And that's not a surprise, because in fact we could just use this line of symmetry here and do the function's axial symmetry in this line. Okay, so we'll do it two different ways, but one way is to see that this 1 here goes here. At 15 degrees we can just come straight across visually. I'm going to use a transparent straight edge here. So I could have come straight across visually here to here. I could have come straight across from here to here to here actually. This point is common to both because the function is dropping down along. Okay, this point is exactly at a half. Here and just below the 0.3. We'll do it on the calculator now as well, but there's actually, these are the points we're going to generate. Okay. Okay, so we'll also generate them based on x values of 0, 15, 30, 45, 60, 75 and 90, and that'll be great. We'll use our calculator for this to get the sine of x values. Okay, so let's change the mode of our calculator around to the table mode, mode 3. Okay, and we'll fill in the sine of x, which we use alpha x for. Okay, so that's the value we want to tabulate. We could put nothing there, or we could just put cos of x in there just in order to compare them. And we don't want to start at 1, we want to start at 0, end at, and say equals to that. Where do you want to end? I'll end at 90. And what will my step be? My step will be 15. Okay, and then you can let the function go, let it go, and we look at the sine values. So 0.258, yeah, we're about there. 0.5 is next. That's here. 0.707 is the sine of 45 degrees, and so on. So we could have done it that way. We've gone up to 0.86 and on up to 1 next, or sorry, up to 0.96 up here, and then on up to 1. So you could have used that, and I should fill them in. In a way, it's a little bit confusing that I put in g of x, because you could end up getting them confused. But basically, what's happening is they cross each other there at 45 degrees, because the sine and cos of 45 degrees doesn't matter which it is; they're both equal. Okay, so again, I didn't have to do any of this, but I'm going to do it anyway now that I have the chance to do a bit of teaching with you. 0.26, 0.5 exactly, 0.707, that's the way I remember it, but I'll put in 0.71. If we're going to round it, 0.87, 0.97, and 1. Okay, using your graph from part B, estimate the point of intersection of y equals cos of x and y equals sin x. As we said, there's no estimating it. It's a very well known fact that they cross each other here. So the intersection point is 45 degrees, because that's the axis, and the so-called x-axis comes out 45, and we're coming up here, and we can even get it off our calculator there. It's 0.707. Okay, now maybe you wouldn't be able to tell that accurately, but you could certainly say it's 0.71. Okay, that's the end of question 12. As always, students, I will see you in the next one.